Petri Ylikoski, who is a professor at the University of Helsinki and also a professor in Linköping University and one of the most recognized proponents of the analytical sociology approach. And so please join me in welcoming Petri.
Thank you. A little bit background for this paper. It started as a paper idea where the intention was to use my ideas about explanation and then contribute to some debates in psychology and sociology. But then I kind of ended up doing ground research, seeing what philosophers of science have been saying about prediction, which turns out to be very little. And then I was considering the economics of the presentation. So I basically given an overview and avoid going to my own stuff. So this is pretty much like an old-time lecture that I used to give in this seminar a couple of years ago. So the main question for this talk is this strange opposition between explanation and prediction. So I try to give you kind of a history of ideas, explanation, why people tend to set these things against each other, while in closer analysis I would say that there's interesting connections between the two things. More precisely, I will structure the presentation in the following way. First I will describe two philosophical motives to talk about prediction. Then I will take a look at theory of explanation literature. Here this book becomes relevant, and describe how the ideas by Hempel set philosophers, primed philosophers to set explanation and prediction against each other. Then I have an interlude. I introduce the concepts, data and phenomena, which I think are useful for making the relation between theories and observations a little bit more complex, but also more adequate in terms of understanding what actually happened in scientific research. And then I describe the philosophical discussion about prediction and accommodation. So basically this is the debate about the status of ad hoc hypotheses. And I hope that we will get something useful out of this. So the first motive, apart from being practically oriented and wanting to predict something, so motive for philosophizing about prediction is this kind of old idea about aims of science. I call it here instrumentalism. This is the idea that science is only a tool for predicting and controlling the world, and all other aims, epistemic aims like understanding the world, explaining the phenomena of the world, these are some kind of excessive, some kind of metaphysical or theological reminders of the past that don't really belong to science. So here's Albert Koffa's definition. For the instrumentalist, science is a prediction machine with pleasant but only psychological side effects. And these psychological side effects are the feeling of understanding and all things like that. So there's a kind of way of thinking about science as a practical tool. This is very natural for engineers, and then treating explanation and things like that as kind of psychological phenomena. They don't really have a kind of objective role in science, but they are something that might motivate individual scientists. But there's no objective way of kind of assessing, for example, explanatory goodness. So these people tend to be dismissive of explanation, and quite often they are also dismissive of theoretical truths about observables. So this was a very popular position in mid last century. So you had logical empirists who were suspicious of all claims made about non-observable things, so they were very suspicious of theoretical entities. So if you cannot observe electrodes, then electrodes are intellectual constructs. You are not taking the talk of electrons in physical theories literally. You treat them as some kind of instrumental notions that you use to organize the observations. We will come back to this. So, and this position is opposed by what I call cognitivism, which says that science should also aim at understanding the world. So it should have also kind of a higher cognitive goals. And scientific realism, which basically, well, there are many forms of it, but basically says that, okay, science should aim at truth and many important truths about unobservable things. We won't go to these debates, but anyway, the point I'm trying to make is that we have this dialectic. Cognitivists and scientific realists arguing against instrumentalists. And what is shared here is that, okay, science is about prediction. And the debate is about what is the added value of explanation and truth. And in this context, you tend to take prediction as for granted. So you could have kind of a philosophical thought experiments where people imagine that we have perfect predictive theory that predicts anything we want, and then they would ask, okay, what would be the added value if that theory also would create understanding? Would we be happy to have kind of a perfect model that we don't understand if it just serves well? And of course, this is a philosophical thought experiment. It takes for granted that that kind of theory without understanding and explanatory considerations is possible. But anyway, so this is kind of biases the discussion to be about value of explanation. The other context where people are talking about prediction is testing. So you have this hypothetical deductive model of confirmation. One of those things that it's quite often attributed to Hempel, where the idea is that the way in which theories get empirical support is by giving rise to implications that can be tested. And if those implications, the hypothesis about the implications turn out to be true, then the theory is confirmed or supported. And if not, then it's falsified or there's evidence against it. So there are different terms. Hempel talks about confirmation. Popper talks about collaboration. So Popper's idea is that you only can basically falsify theories, but then he had a problem that, okay, we have a theory that fails to falsify. Should we say that that theory is equally good as any theory that hasn't yet been tested? And then he started to talk about collaboration, but saying that that's a very different thing from the confirmation, and nobody never fully understood what's the difference. But anyway, that's a terminological confusion. But anyway, the idea is that you aim to falsify the theory, and then you can make inferences. So this is basically modus tollens that you learned in first logic course you take. Modus tollens, you have premises, they have implication. If implication is untrue, then one of the premises or all of them are untrue. So in this case, you have a theory and auxiliary assumptions about observational instruments and whatever. And then if the hypothesis, the prediction turns out to be true, then there's something wrong with the theory or the auxiliary assumptions or all of them. And then there's a lot of debate how you could attribute and whether there are any principles for inferring the falsity from the hypothesis to specific part of this whole. But that's kind of a philosophical technical debate that has been going on for 40 years. Not much progress there. But anyway, in this context, people are talking about prediction, but it's very broad notion of prediction. So if everyday notion of prediction is the prediction of future events, in this prediction is basically just a derivation of any empirical testable implication of a theory. So this is a kind of a very broad notion of prediction, and most of the philosophical debate about prediction is about prediction in this sense. But anyway, this is an implication that you kind of reduce the thinking about empirical support of theory to the predictions, and then this sustains this highly abstract notion of prediction, which makes senseless to have more detailed classification, for example, of different sorts of predictions. So these are kind of the two motives that we'll encounter in the future discussions that I will describe. So let's go to the theory of explanation. First, there's this, the most famous theory of explanation there is Carl Hempel's theory, covering law theory, Hempel-Oppenheim theory. The original theory was presented by Hempel and Oppenheim in the late 40s, but then most of the writings about this theory has been by Carl Hempel. So the basic idea of the theory is very simple. So the idea is that a scientific explanation is a derivation of the thing to be explained from the general laws and the sentences describing the facts of the matters. In combination, the idea is that explanation is a deduction from these facts about statements about facts, statements about laws to the thing to be explained, the explanandum. And then Hempel adds this kind of idea that, okay, this is actually a general theory that could be also applied to predictions. So he's saying that predictions and explanations have the same logical structure. So basically, you use the same formula, modus ponens, to analyze both predictions and explanations. So the only difference is in terms of the time. So in the case of the prediction, the E is yet unknown, so you derive something from something that you know to something that will happen in the future. And in the case of a postdiction or explanation, you already know E and then you derive it. And this is kind of for philosophers, this sounds very neat theory in a sense that originally there was the intuitive idea that explanation and prediction are very different thing, and then it turns out, okay, they're actually the same thing. And then this also kind of legitimizes explanation, because in the 40s, the idea of explanation was kind of a wishy-washy idea, but this kind of gave an idea that, okay, you can have a formal, exact theory about what is a scientific explanation. This gave rise to a lot of hopes. Just to mention, this is quotation from the paper from 58, Theoretician's Dilemma, where the main argument in the paper was how you can basically reduce all theoretical concepts to observational concepts. So this shows the kind of a empirist context in which this theory was presented. And this was very highly influential. So Hempel made explanation interesting. So this is happening in 1950s. So what it seemed to give is a precise philosophical analysis of a notion that has been obscure earlier. It seems to be metaphysics free. So remember, at this time people were logical positivists. They were against metaphysics. And what is more metaphysical than causation? Causation talks about powers and counterfactual possibilities and things like that. And these are something that any empirist is suspicious of. So empirists wanted to have some kind of a reductive theory of causation, reduce causation to regularities or something like that. But in this theory, although it's compatible with the idea that some of the laws are causal, it doesn't presuppose anything substantial about causation. It was an appealing theory. And then it seemed to be elegant and unified. And this case then gave a rise to what we philosophers call explanation industry. So if you look at the literature in philosophy of science for the last 70 years, probably the biggest topic that has most articles on is scientific explanation. And most of this industry was built around Hempel's theory. So until beginning of this century, for the 50 years, most of the discussion about scientific explanation started always with the Hempel's theory and then started to describe known counterexamples of the theory. So the discussion started in the 50s and 60s. People tried to come up kind of a counterintuitive consequences of theory and then try to argue, okay, there's something wrong with the theory. But anyway, so this industry continued. And when people started to formulate new theories, they were basically starting from these anomalies for Hempel's theory and then tried to build up a new theory based on those. Only in 90s you had people who kind of start from the scratch or don't start from Hempel but start from somewhere else and then end up explaining what's the problem with Hempel's theory. So, and also, so all the discussions about prediction in explanation literature are in this context. So people try to find counterexamples of the symmetry thesis, which was the thesis that explanation and prediction have the same logical form. So then the industry went on, so by the detail, in the 60s and 70s people started to develop theories about statistical explanation. This was very thorny because in statistics, because Hempel thought that you have to have an inductive statistical model of statistical explanation, but then there's no inductive logic. And then some people came up with a deductive theory of statistical design. But then after a while, the people came up to the conclusion, okay, statistics is not enough, you need causation. And then they first started to incorporate causation to the covering law theory, but then they found out, okay, if you already have causation, you don't really need all this logical stuff. So then people started to talk about causal processes, mechanisms, and so on, gave up the idea that the explanation has to be a logical deduction between sentences. And also, at the same time, people, especially in the 80s, people started to become more and more realist in terms of the kind of basic attitude towards science. So, whereas in '58, Hempel was still trying to reduce all the theoretical notions to theoretical notions. What it means, I don't yet understand, so that's a kind of a philosophical distance. But anyway, the scientific realists started to emphasize the importance of theoretical concepts and their legitimacy. And also made the claims that if best explaining scientific theories postulate that they are electrons, then we have a good reasons to believe that they are electrons, although nobody can observe them. So this is the basic debate. So what kind of things philosophers found in this debate? So remember, they were primed to ask, what is the difference between explanation and prediction in order to show that Hempel is wrong? So first they came up with cases where you have predictions without explanation. You have lots of examples, but basically the same form. You have some kind of correlation, diagnostic information, and then you show, okay, with this diagnostic information you can make the predictions, but you cannot explain. And this is a counterexample. So you need something more than Hempel's theory requires, and then the suggestion is that you need causation. And then you have an idea that you can have a false theory or false model that you know that makes false assumptions, but is still useful in prediction. And in the context of prediction, we don't care about whether the model is true or not, but in the case of a explanation, we want them to be true because we want to infer about the things that produce things and so on. So then there's a sticky questions about theories that involve idealizations that are not fully true, but let's skip them. But anyway, these are one kind of a set of findings that try to basically contrast explanation with mere prediction. So kind of some kind of a false theory or theory that is lacking, especially of explanatory qualities, but still could predict. Then the other people were also arguing the other way around, so they were trying to show that there are explanatory theories that might allow prediction. So the primary example is a theory of evolution. It cannot predict the cause of evolution, but it can explain. Think about the long necks of the giraffes. There's no reason to predict that there would be giraffes or that they would have long necks, but it's perfectly explainable by the theory. So it might be that we are missing, we cannot predict because we don't know all the facts. Okay, this is kind of an argument that is kind of still following up the Hempelian thinking about explanation. So we don't know what kind of particular facts to insert in the deduction. So that's why we cannot deduce or to predict the right conclusion. But then there were other considerations that refer to the fact that, okay, we might never know the historical facts about evolution, or the process might include stochastic, probabilistic processes that make precise prediction of the specific outcome impossible. Think about evolution. We cannot predict what kind of mutations there would be. Then you have a random drift related to the, any limited population and so on. So we will still say that we can explain what happened, although we can predict or derive precisely the thing that we are interested in explaining. So this is what we can learn from this debate about prediction. What is interesting that they never developed, and now remember that the explanation industry, philosophy of explanation or theory of explanation was the biggest industry in the whole area, but they never developed any philosophy of prediction. So this is a quotation from Alex Broadbent's book about what is a philosophy of epidemiology, the first book about the philosophy of epidemiology, and there he kind of summarizes philosophical attitude towards prediction. So predictions are something that come out of the theories, and they are interesting for that reason, but then there's not much reason to figure out, okay, how you get predictions out of the theories. So there's very little discussion about classification of different sources of prediction. I know there are some philosophers, economists, who are discussing different sorts of predictions, but they are mostly commenting on economists' talk about differences between qualitative and quantitative predictions and so on. So they are not developing any kind of philosophical taxonomy of this. And also, most of the predictions in the debate are kind of just predictions, and there are not much discussion of, okay, what makes a prediction a good? Because prediction can be just a hunch, or it could be theoretically justified prediction. And then the whole thing, how you justify predictions, is kind of completely missing. And think about policy context. You have a competing predictions, how you choose on which to act. Or you have predictions, what kind of evidence thresholds you should have to accept, to take some prediction seriously. And all these debates are basically missing from the philosophy. This is a bit surprising. There's also some surprising things. Another thing is that although in recent debates about explanation, the notion of intervention has become very important. So this is James Woodward's book. So if you have to read one book about explanation nowadays, it's this book. People are saying that Woodward is in Hempel, not because his ideas are similar, but his position is now similar in a sense that nowadays when young Turks are writing the papers, they are starting from a Woodward and then try to find something wrong with these ideas. But anyway, he has a book with the title Making Things Happen, and the basic idea there is the idea of intervention as a key to understanding causation. It's basically a philosophical reconstruction of the kind of thinking you have in thinking of and models of Julia Pearl and other computer scientists and so on. So although he's talking about a lot about interventions, he's not really talking about prediction. So there were 33 occurrences of the word prediction into the book, and I checked them. Some of them were in the citations, and some of them were in sentences like description and prediction. So he's not explicitly discussing that. That's I think it's a little bit surprising, because quite a lot of interest about prediction is actually related to consequences of all kinds of interventions. And then in the debates there was kind of a downplaying of prediction, but then there are some cases, and this example is from the Broadband's book. So there might be cases where prediction requires more explanatory knowledge than explanation. So the idea is that the example is here. Okay, suppose that we have better or current or better knowledge of the relation between smoking and lung cancer. And then we know that, okay, one of the causal pathways by which smoking causes lung cancer is because it contains tar, and tar has carcinogenic properties. And okay, we could go deeper and deeper in acquiring this mechanistic knowledge. But can we still make a justifiable prediction that if we reduce tar in cigarettes, that will reduce lung cancer? And but that has been tried. People have tried to reduce the amount of tar in various ways in cigarettes, and it has turned out that it hasn't reduced occurrence of lung cancer. And that's because there's a kind of a spoiling causal mechanism or causal factor, which is that smokers are responding to the reduced amount of tar in cigarettes and increasing their smoking. So the effect basically remains the same. Now I think this is I haven't really thought it through, but I think this is an interesting case in the sense that we have to be careful. But whereas Broadband is building this as an argument that, okay, epidemiologists shouldn't care about mechanistic knowledge, they should have kind of other kind of knowledge. I think this demonstrates the importance of mechanistic knowledge, but it shows that in some cases prediction presupposes more mechanistic knowledge than simple causal explanation of the fact. But anyway, this is something to elaborate in the future. And also, this was in my original plan, but I will basically skip it. This is the idea of look at what kind of theories that are strong on predictive implications, whether they are also strong in terms of the explanatory qualities. Because much of the discussion about explanation has been, okay, what makes explanation? But then you can also ask that, okay, how people, especially scientists, judge goodness of explanations. And then we have this old paper where we distinguish 5 different dimensions in which people which people are using when they are saying that some explanations are powerful or deeper, something like that. And it seems that that there's a kind of a correlation between explanatory goodness and then also being viable for further testing. But anyway, let's skip this because this gets very technical. Let's move forward with the interlude. So, as I said, much of the discussion is in terms of the theories, then deriving hypotheses, and then facing hypotheses with the observations. So you have theory, H, hypothesis, and O, observations. And I think this is too simple. And okay, there's a Woodward again. He has two excellent ideas. One of them is related to explanation, another one to this distinction between data and phenomena. So the basic idea here is that we have to complicate things a little bit. So they introduced the distinction between phenomena and data. And let's start with the data, because data is something that we understand better. So evidence is, so the data is something physical. So it's measurements, descriptions, photographs, reports, and so on. And these are products of causal processes. If you do the experiments and then your instruments show some readings, those are outcomes of causal processes. If you are doing register research, there's a causal process by which things end up being in register and so on. And their point is that we are using this data not, I'll put it another way. Their claim is that theories are not directly facing the data, but we are using this data to make claims about phenomena, and then theory explains and predicts these phenomena. So think about, for example, very simple example. We are measuring the melting point of lead. So how do we study that? Okay, we do experiments in the lab, and then we do the measurements. And then we have some kind of physical theory that explains the melting point. But physical theory doesn't explain the individual data readings. There are a lot of random variation there. We don't actually necessarily know what are the sources of the variation. We are explaining something that is abstract from these particular pieces of data. And that's the target for explanation. So, and what the phenomena are, there are some kind of a stable and replicable effects or processes that the theories are targeting. And then we can say that, okay, the phenomena provide evidence for a theory, data provide evidence about the phenomena. Important thing here, I think, is the contrast between the phenomenon and the data. What the phenomena are, that requires, I think, a further articulation, but I think the contrast is important. So idea here is that, okay, data are these material and public objects, and then the data is a product of complex and idiosyncratic causal process, depending on what kind of experimental setup, for example, you have, or what kind of observational arrangements you have. And usually it's not possible to systematically explain all the details of the data, but it's very important to understand the causal processes of the data production. And second, there isn't that much point in replicating the data, but to get a better data, and maybe data with the alternative processes. And when they describe this distinction, they use an example, parapsychology. So problem with parapsychology is not that they haven't got interesting observations, interesting data. But what they have failed to do is to show that these interesting data constitutes an interesting phenomenon. So they cannot replicate their experiments, or they can replicate them, but nobody else can replicate them, and so on. So they fail to kind of demonstrate, to show that this data gives rise to this phenomenon. And of course, when you think about phenomena, it's also important that there should be alternative ways of identifying the same thing. So when we are doing an experiment, we start with a real-world system, then we build up an experimental system. We might shield out some causal processes, effects. We might randomize. We might try to keep things constant, and that creates for us an isolated experimental system. And then we manipulate the system, make observations and measurements, and then we have the raw data. And Evidential relevance of this raw data depends on what are the causal processes that produce the data, so how did the system, the experimental system work, but also what could have produced it. So to justify the claims about phenomenon with the data, you have to show that, you understand how the experimental system works reliable, and also rule out candidate causes, alternative explanations for that data. So you don't have to have full theory. Think about Galileo and the telescope. He didn't have a theory of how human eye works, but he could demonstrate that he can make a reliable observations with the telescope. But also he had kind of a understanding what kind of things might confuse the observations. So if you have some smudges on your lens, that might create observations that are not really that don't justify claim inferences about something happening in the moon. So you could talk about theory of data production. So this covers all the causal processes that involve in the production of the data, including how human perception works. And then these theories tell about the reliability of the procedures. And here, important thing is also the skills of the experimenters. And then, with the help of these, you understand and justify the claims about the phenomena. So this is the basic difference. So we use the data to decide between competing claims about what is the phenomenon, is there a phenomenon, and what kind of properties it has. And then we are confronting our theoretical claims with those claims about the phenomenon. So the crucial issue here is not whether the theory is logically compatible with the phenomenon, but does it actually explain what the phenomenon. And these are independent. So there's a lot of discussion about theory ladenness of observation. And this is a very natural way of understanding it. So theory ladenness of observation means that you have a theory of data production. You cannot infer observations without this theory. But also it's not theory laden in a sense that observations presuppose the theory that you are testing, because many of these theories that you are using to understand the production of the data are completely independent of the theory that you are testing. Of course, there are some cases where there are connection, but these are usually tricky cases. So you move from the data to phenomena, and the reason why I'm bringing this here is that we have huge discussion about replication crisis, where people are discussing bad research design, insufficient sample sizes, p-hacking, overfitting, Gardner forking paths, publication bias, and so on. And in my analysis, this is basically about inductive inference from the data to phenomena. So what p-hacking and others allow us to do is to report as phenomena things that are just patterns in the data. And this is the context where people are mostly nowadays motivated to talk about prediction, and they are talking about out of the sample prediction. And I think this is an extremely important point, but this is not a kind of a context where you have an opposition between explanation and prediction. Because no matter how strongly you favor explanation, you will still like to have the things that you try to explain with your theory to be real. So this is a problem of inductive inference. And my idea, although I explain it with the example of experimental research, I think this can be generalized. So the data doesn't have to be experimental. There could be observations, naturally occurring data, registered data, and so on. But still, the point about the origins of the data is important. So the theory of data generation is still important. It also might be that the theory, general theory is weak, so it only gives a very rough explanation of the phenomenon. It's only able to explain stilicized facts rather than specific details about the effects. And it's also possible that we might have a growing body of knowledge about the phenomena without explanatory theories. And this is actually the case, I think, in much of the psychology. Think about behavioral economics. We don't really have a theories that explain human decision making, but they have identified phenomena related to decision making. And this is more broader claim. This is a nice picture that I found a couple of years ago from the internet. This is a classification of all kinds of cognitive biases psychologists have found. And this is very cool, but this is basically just a list of phenomena in my sense. So psychologists have some ideas what would explain these biases, but there's no strong theories about cognitive processes that would explain these. You have a debate whether any of these are real or how broadly they apply, but these are questions about the data phenomena inference. So that's really our tactical questions, what kind of a phenomena we have. But we are lacking the systematic theory to explain them. And I think this is important because much of the debates in philosophy are talking about contexts where we are testing theories. But in these cases, we don't really have theories or strong theories. And what we are really talking about is question whether these are real phenomena. So, some take-home messages from this. The abstract talk about hypothesis testing makes invisible the distinction between this data to phenomena inference, which is different from the relation between theory and that explains the phenomena. And also, the assessment of empirical evidence is heavily embedded in explanatory reasoning. So, and I think this is very important when we try to understand prediction, because we cannot understand and assess the status of prediction without having causal understanding of the process. And also, interesting observation that, okay, experimental control requires causal understanding, and although Woodward says that the phenomena, things that theories explain and predict, hasn't again discussed much prediction in this context. And of course, we have to, well, we could expect more work on classical phenomena, but I think the contrast is very useful. So let's go to the accommodation, and this brings us to the interactive part of the presentation. So we have two scientists, Penny predictor and Annie accommodator. I think Annie is accommodator because she doesn't have a real gloves to do the experiments. So, Penny develops a theory and derives a novel prediction, and then empirical test confirms the prediction. So that's kind of a standard deductive way of proceeding in science. Then we have Annie, who sees the data and develops the theory. She doesn't know the Penny's theory, and then she says, okay, I can explain the data. And now the question for you is, and this is everybody should answer based on the first intuitive response, whose theory is better supported, Annie's or Penny's theory? So so you have predictivists who say that, okay, only Penny's theory is properly tested, so it has better support from the same evidence, and then you have accommodationist who says that, okay, both theories are equally well supported by the evidence. Okay, who's predictivist and who's accommodationist? So, predictivist, please raise your hand. Only one, two, okay. So okay, the whole philosophical debate has been to explain this intuitive judgment that people have that, okay, there's somehow more support for the Penny's case than the Annie's case. But to get the problem, we only need to ask question, and of course this is a highly unlikely, but it's allowed in philosophical thought experiments. What if they come up with exactly the same theory? This leads to problems, because if it's exactly the same theory, it cannot be that when Penny is presenting a theory, it's better supported when Annie is supporting the theory. And also, even if they work without knowing each other, and when they meet, okay, someone should change the evaluation of the support for the theory, but who? And on what grounds? So this creates kind of a formal problem. So to get grasp of this problem, let's first get in some concepts. No, before that we have a very famous accommodationist, so this is not kind of a recent philosophical idea. So John Stuart Mill said that, okay, predictions might impress ignorant vulgar, but proper scientists don't really get excited about the predictions because they're just showpieces. Okay, so the usual way that people have been discussing about this is in terms of ad hoc hypotheses. Okay, why philosophers are talking about accommodation? That's because talking about ad hoc hypotheses kind of biases the whole debate. Because most of the time, when people are talking about ad hoc hypotheses, they are assuming by definition that there's something improper happening. Think about how you would characterize something as ad hoc. Of course, there has been a philosophical industry on this topic too. People have tried to develop a general theory of ad hocness, haven't been very successful. This is a recent summary, and written by historians, philosophers, and scientists over whether or not a hypothesis was ad hoc and therefore illegitimately proposed is energy wasted. So Hunt's point is that, okay, you should always say what's wrong with it rather than just label it ad hoc. And he also says that there's no systematic way identifiable in the way in which scientists talk about ad hoc hypotheses. So, the accommodation is a natural word, but it's so awful word, difficulties in pronouncing it, so I'm talking about post hoc hypothesis. So, post hoc hypothesis is something that is developed after the observations, but it's neutral with respect to its quality. So, and the important point is that it's not chronically untestable, because quite often people say that ad hoc hypotheses are untestable, and it's a little bit ambiguous whether, okay, whether it's testable with the data in hand that it was created to explain, or untestable in generally. But post hoc hypotheses are not by definition untestable, because you can always do the further experiments or further observations about its assumptions. So we could say that ad hoc is a subset of post hoc, but you have to take into account that this is not based on any kind of research, so this is just an illustration, and so you shouldn't infer anything from the sizes of the blocks. Okay, then, because I've been doing a lot of distinction, so what kind of predictivist you are? So you have a first distinction between global and local predictivism. Global predictivism says that theory which successfully predicts is always superior to accommodating theory. And then you have weaker thesis which says that it's sometimes superior to accommodation. So this latter allows that there are some special circumstances where accommodation is better than prediction. Then the other distinction is between strong and weak predictivism. So strong says that prediction is intrinsically superior to accommodation. So there's something interesting about prediction that makes it better. And then weak predictivism is a little bit more complicated idea. There's the idea that in a cases where novel predictions are valuable, there's something about those predictions, but not that the fact that they are predictions, but that somehow the prediction correlates with something, some interesting properties that have evidential importance. And then, in this context, people are talking about novel prediction. This can have different forms. So sometimes novel prediction means unique prediction. So this kind of a prediction theory has that no other competing theory has. So it's kind of a unique prediction. And of course, that's a nice thing to have, but it doesn't really, it's not really applicable to these debates, because in this case, we don't have any theory that accommodates the facts. So we have temporal novelty, which is that the case where the phenomenon is a novel for a theory only if it was unknown at the time of the theory that was formulated. So this is things that facts that are predicted that are found out only after the theory has been formulated. And a crucial thing is the time. And then there's a use novelty or heuristic novelty, which means that the phenomenon is novel for a theory if it was not used to construct that theory. So this is a special case of that, maybe. Okay, so let's start with the strong predictivism. Okay, the basic problem with the strong predictivism that starts with the temporal novelty is that it's very hard to justify why the time matters. No matter how you understand the relation between the theory and data, why does it matter when you find out about the facts that constitute the evidence? And I don't think nobody nowadays supports this. So it was kind of was probably presented in a debate as a proxy for the use novelty. And this is something that people usually discuss, which is the idea that, okay, you cannot utilize the theory when formulating the, you cannot utilize the observation to formulate the theory without reducing its evidential quality. But okay, but this sounds very plausible, intuitive, but it has an unintuitive consequence. Because if you think that, okay, not using the evidence is a crucial thing, then you give basically a practical advice for scientists. Don't read the research literature. Be ignorant of existing research, because when you formulate your theory and it turns out to be right, it has stronger support than if you had read the literature. And this sounds very implausible. I think there's a kind of a strong sense in which we expect that the scientists take into account all existing evidence, and you are somehow in better ground. But of course there might be some way of getting out of this, but this is the reason why strong predictivism is usually given up. So then let's think about how we could otherwise solve this. There's a lot of literature about different Bayesian theories, using Bayesian statistics to analyze these things. But I think its summary kind of shows that you need some other resources. So Bayesian theory has been taken to be valid because it favors novel predictions, but also because it favors accommodation, but also being false because it does these both things. So you need. The point is really something about else than updating your beliefs according to probability theory. And then there's also another sub-industry about looking how scientists are in the past, in the history or in current science, have been evaluating ad hoc hypotheses or cases of accommodation and prediction. But then in all these cases, you have huge controversies how to interpret them, and they're complicated cases because when some significant theories are accepted, so even if you have their famous and magnificent predictions, there are also some other things happening at the same time, and it's very hard to say what actually convinced the scientists. But there's also kind of methodological point that, okay, even if we could have this data about what scientists judge about these cases, there are still cases that fuel debates that doesn't really kind of solve them, because we still have to understand what's happening there. And that's why let's take a look at a couple of ideas, what might justify the idea that prediction is better than accommodation. The first is related to idea of testing. So this is a weak predictivism. So the idea is that, okay, there is nothing in itself in prediction that is favorable for empirical support, but in a cases of prediction, you usually have a asymmetry in severity of testing. So when you are predicting things, you have usually designed your setting in such a way that it makes, if it's a well-done experiment, well-designed experiment, highly probable that the theory survives if it's true. And this is not the case for the accommodating theory, because there's more room to move around, and as it wasn't, the experiment, for example, wasn't designed to test the accommodating theory. There's something intuitive here, but it's very hard to say whether this generalizes. But in any case, I think the important point is that this is only an argument for local and weak predictivism. Second, it depends always on the details about the research design. So what kind of causal explanatory reasoning is involved about the data production? So this involves explanatory reasoning in any case, and it only applies when you actually have a severe test. So that might be a reason why it doesn't generalize. So you could basically analyze independently how good test it was. But of course, it's conceptually possible that in some cases, in some very badly designed tests, it actually favors the accommodating theory. So this is an advantage prediction is assumed to have. The other advantage is that there's some kind of disadvantage with the accommodation. And I think this Peter Ylikoski's theory captures the intuition of many. So Ylikoski says, when data need to be accommodated, there is a motive to force a theory and auxiliaries to make accommodation. The scientist knows the answer she must get, and she does whatever it takes to get it. The result may be an unnatural choice or modification of the theory, and auxiliaries that result in a relatively poor explanation and so weak support a choice she might not have made if she did not already know the answer she ought to get. So the idea is here that there's some kind of there's more room for kind of doing some shady stuff. So this is not a claim that you always do it, but there's kind of a general suspicion because it's possible. And he also assumes that, okay, this is not necessarily done consciously. So it's possible that people are kind of fudging things unconsciously. And because that's possible, it's kind of it justifies the asymmetry between prediction and accommodation. So even though for ideal epistemic subjects who always know all the facts and can make all the inferences, there is no difference between accommodation and prediction. For actual humans, inductive support is translucent rather than transparent. And for this reason, because we don't really know what could have happened, then we tend to think that accommodation is worse. Again, this is the only argument for local and weak predictivism. It's kind of defeasible if you can demonstrate that nothing fishy is happening, no fudging is happening, then this takes away the difference. But also, this leaves things a little bit kind of undecided because he's talking about these things in metaphorical terms. He's talking about forcing, unnatural changes and so on. It doesn't really tell us what's wrong. But of course he's supporting an inference-based explanation, so clearly in his theory explanatory considerations are again very important in deciding whether there's fudging happening or not. I'm a little bit undecided about severity and accommodation, but as a methodological point, I came up with this scheme to kind of take air out of these intuitions. So I have 4 cases, and then I will finish. So the first case is this typical case that people have in mind when they're talking about ad hoc hypotheses. So you have a well-established theory. So this is the theory that does the prediction, this is the theory that does the accommodation, this is the old evidence, and this is the new predicted evidence. So in typical case, when people have strong intuitions about the ad hoc hypotheses, we have existing theory, and then we have another theory which only explains the new data. And then it's quite clear that, okay, the old theory is better, and it's also understandable that, okay, the accommodating theory, the ad hoc hypothesis can be anything because you don't really have any kind of constraints on the theorizing. But again, it is clear in this case that the pre-theory is more strongly supported than accommodating theory, but is this really because of the prediction or because of the older accomplishments of that theory? So let's add parity. So let's consider a situation we have 2 theories that can handle both the same set of evidence. So this is much more rare case, and it's much more difficult because here you are still accommodating this new evidence, but the accommodation would still have to be compatible with the old evidence. So then the crucial question is not whether they can cover all the evidence, but which theory does it better. So does it explain, do they explain all the evidence equally well, or which one does it better, and of course, which one fares better in the future? Usually these 2 theories are kind of closely related. So they are variants of each other. So and that makes understandable the similarity of the support. So although these people deserve credit for bringing in the new evidence, it's unclear whether this theory is better supported than this theory. Then let's take another case. This is more like a psychology case. We don't have a earlier track record for the theories. You have basically just theories. Provide some kind of theorizing that produces hypotheses, and then you test them, and then some of them turn out to be right. So in this case, and I think this is an important point, you can actually, because Lipton's theory was that fudging is only possible in the case of accommodation. But I think in this case, you can have fudging also on the prediction side. Because it might be that, okay, you are reporting only those theoretical ideas and hypotheses that turn out to be true. Or what psychologists call HARKing, hypothesizing after the results are in. Where basically you do the experiment, and then you see that, okay, your theory fails, but then you come up with a new theory that is compatible with the results, and then present that as original theory. So that's basically just lying about the research process, but it's basically the suspicion we could have. one form of fudging. But in any case, be it as may, I think in this case it's too early to decide. It's just rather than discuss which theory is better supported, which more deserves our support or acceptance, we should basically just look for new additional evidence. And then finally, think about the imbalanced case, other way around. You have a new theory that only makes a new prediction, and then you have old theory that has already some accomplishments, but also can accommodate the evidence. And I think in this case, the accommodating theory is better supported. Of course, again, these people deserve credit for producing new evidence, but that doesn't mean that their theory is better supported. It's only worry in this case if the accommodation, the post hoc move, seriously diminishes the explanatory power of the theory or its ability to survive further tests. So, take-home message from this. Active testing is highly reliable, but doesn't mean that the predictivism is true. Second, nothing wrong with a good quality post hoc theorizing. The question is really about how you accommodate the data, not whether you are accommodating. So rather than slandering the hypothesis, saying that it's ad hoc, you should say what's wrong with it, what kind of undesirable qualities it has. And then, in the cases where prediction beats accommodation, and I am not denying that they are such, it's important to understand that the grounds are usually explanatory. So we are making claims about the quality of the post hoc hypothesis, or about the process of producing the data, alternate explanations of that. And that's why it's not really fair to put prediction and explanation against the other. And finally, methodological point is very difficult or maybe impossible to evaluate kind of a point by point what kind of support piece of evidence gives the theories. So I think it's much more realistic to discuss these complex cases rather than the Annie Penny case where you are only discussing one set of experiments or one observation about the phenomenon. I think that's enough. I hope you got something out of it. Thank you. Do you still have the intuition that the prediction is better? Yes.
Well, actually, better. I think that when I was reading, for example, the dissecting of Peter, this distinction between prediction and explanation, I never saw them as separate. Because I convey this vision of this contrast by hypothetical deductive statements. And thus I mostly take predictions as logical consequences of theories that then you falsify. Therefore, if you create a theory that cannot make such logical deductions, in that sense it cannot predict, it's a worse theory than another one that can do that. So for example, Gianluca has been discussing long ago this Boudon's cognitive rationality versus rational choice theory, right? And yeah, we agree that Boudon might be right, but the problem is that his theory cannot be falsified because you cannot make logical consequences that can be falsified. Therefore, predictions, it can make any prediction. So compared to rational choice, which is more restrictive, it is false, but it can make those predictions. So in this sense, it is better rational choice than Boudon's. So that's the way I take it.
Yes, Boudon's theory is kind of denial of rational choice theory rather than substantial theory, and that makes it kind of less powerful in terms of explanation because it doesn't really explain why things are this way rather than other way. But then I think it would still be a better supported theory than the rational choice theory.
But of course, like when you say that tomorrow it will not rain and it will rain, yes, you will get any support possible, right? and that's Boudon's theory. So, yeah, I mean, you end up in the same point as before, I guess. So, I don't know, how much is that helping?
I don't know, maybe it needs to help. I think one of the things that we can learn from this, I was reading this philosophical literature, and this is kind of philosophical, methodological thing to demonstrate with other thought experiments, is that you start with these very simple thought experiments, and then you have intuitions about them. But then you start modifying these experiments, and depending how you modify, your intuitions will change. This raises two issues. First, that maybe should vary about very simple thought experiments as a source of insight. And second, maybe the intuitions are something that are not evidence, but something to be explained. So then we should understand why our intuitions change systematically with these changes in thought experiments.
But I think, though, it's interesting when you said that, for example, the theory of evolution does not predict. I mean, is this the case that where random processes take place or chaotic systems, you cannot make predictions, but you can make good explanations?
Yes, there have been some discussion about the evolutionary theory, and of course it's kind of tricky, because you cannot say that evolutionary theory doesn't predict anything.
Yeah, sure.
So the case was that it cannot predict the specific evolutionary outcomes, but you can give predictions about increasing adaptiveness. You can also give a kind of probabilistic explanations about the influence of random drift and all kinds of things. But many of these explanations are kind of probabilistic explanations, so what it can be expected to happen, and also kind of describing at a qualitative level what's happening, rather than giving precise quantitative predictions. And of course they are testable and can predict things in a sense that you can build up models and make specific predictions about what would happen if the world were like this model. But then I think the reality is such that you don't have that much confidence in those models, and also that there's not that much value in predicting specific outcomes. But you can make predictions about what is the probability of extinction if the population of certain species goes below certain threshold and so on. And I think these are reasonable predictions. Yes?
I just had a question more about how science is actually practiced, which is that are there people, if you look across scientific disciplines and you try to focus on the theorists, whoever those happen to be, are there really people who are one or the other, who are predictionists versus accommodationists, or is it actually the fact that those two are often integrated into the same person? And to what degree are these different types actually represented across different disciplines? Are we saying, I mean, I'm just curious if we think about what's actually happening in the real world, what's going on?
That's actually quite an interesting question, and if you look at the case studies about history of science, it doesn't probably show that people have consistent predictivist inclinations. It's more like it might be like a temperament, but also it's highly context sensitive in a sense that in many of these scientific debates, people are accusing of each other of making ad hoc hypotheses, and then their assessments are kind of inconsistent, depending on whether they are discussing their own theory or on some other theory. So it might be that this is kind of a form of talking about things rather than systematic philosophy, and then just philosophers are just trying to make them kind of a principled thing that people should accept.
I'm trying to think back to my undergraduate years when I was still in the applied physics department before I became a failed physics student. But there were people in this department, which in applied physics, of course, is kind of very mid-level, right? You're not trying to uncover new fundamental physical phenomena. You're just kind of, they were more or less working out what are the consequences of quantum theory, right? And they had people who were theorists, but it seemed like theorists always had, the one guy that I'm thinking of had two hats on. So he was doing things where he's trying to derive some predictions, but very often it seemed like he was working with experimentalists and trying to figure out why they got the experimental results they did. So it seemed like he was doing both things at the same time. So I think that's just, it sort of speaks to, I don't know how fundamental this conflict is, right?
Yes,
It also kind of denies the scientific process, which is that, I mean, for a lot of cases, within even a single project or something that leads to a single piece of research, right? In fact, you've gone through many iterations of experimentation and theorizing before you even present what your results are. So to act as if that is one instance of prediction or theorizing or data collection is kind of, that's just not true.
Yes. So of course, as a philosophical fiction, it's possible to have a theory that's kind of always progress only by making predictions. Yeah. But if you look at real world theorizing, it's mostly about making predictions, accommodations, and then modifying a theory. Mm-hmm. So it's not really one or another. And also in this context, I think that was my point about the broader context, is that it doesn't really make sense to focus on this one instance, but it's more holistic thing. And also that it's very, the contrast when you start to think about, okay, when you are making a kind of a proper prediction, you have engaged a lot of explanatory reasoning already. So it's hard to distinguish that reasoning that is involved in an accommodation, if it's done kind of properly and you are respecting the constraint. Of course, there's a possibility that you are fudging there and doing something fishy. But I think those cases can be identified independently of this prediction thing. That's why probably my tendency is to kind of play down the importance of this debate. Yes.
Yeah, I'm also thinking about, I mean, you talk about theory, but of course, I mean, I think that today, I mean, what do we mean with it? What is a theory, really? And are there certain kinds of theories that are preferable to other theories? And because now, I mean, we're almost in the, say, opposite world of evolutionary theory, that we can envision a situation where we can produce enormously powerful predictive machines in some ways that also are not just tailored to one specific case, but actually has some kind of universality in it, that it can predict outcomes very, very. And that is a question, I think that some people perhaps would think that would be a kind of theory, because it was inductively accommodating data in one instance, but then it has been refined, and now it's very powerful to. But of course, others would not think of that as a theory, well, I think I would say, but this Duncan Watts AGS article, for example, but that many social scientists will think, well, it's not really a theory unless we somehow link it to some kind of actors, understanding, etc. But then, of course, the problem is that those theories are pretty poor in terms of, I mean, they are vague, they are easily adjustable to any kind of situations. So we're kind of facing some kind of trade-off between kind of false theories that are very rough theories that we can apply, but then we know, well, we don't get anything out of them in terms of predictive ability. We know already before that they are not really good replicas of what actually goes on in reality. It's very kind of stylized, simplified. And then what are the arguments, so to say, for that kind of theory rather than a theory that of the predictive machine kind? And I mean, in the Penny, you didn't really talk about what a theory was there, if it was just because I think that support for theories is not only how well they accommodate or predict data, but we often add other aspects to what we consider to be a good theory. And the question, what is that? Is that perhaps something we shouldn't do any longer, or should we? And it's those kinds of arguments that enter into.
Yes, this is very tricky. So, okay, most of the discussion makes sense when you have kind of a something like you might have in physics, in a sense that you have a theory that actually have accomplishments. But think about psychology. You haven't had proper theories for decades, and they are not expected in the near future. So, what's the whole point of this debate? But also, what do you think about the theories? If you think about theories as kind of theories about, let's say, social mechanisms. In these debates, you kind of a general theory that makes a prediction about the case. But when you're using the mechanisms, what you find out that, okay, this mechanism doesn't apply to this case, rather than that the mechanism doesn't exist. So it might be that in this case, some other mechanism worked. So it's unclear how you infer anything from the failure. So think about you are explaining cases of segregation, and then you have a multiple mechanisms that could bring about segregation, and then okay, you show that okay, some of them is wrong, but what that's so in general about that theory, except that it was precise enough that you can show that it doesn't apply in this case. So this is it's a crucial question, what is a theory? But that's
No, I think, I mean, if you look upon, say, empirically in journal articles, of course, often what is theory is just past empirical research of others, and that you then generalize a little bit, or they have generalized, but it's very unclear what makes them, who gives them the status of a theory versus just some
hunch.
Yeah, exactly.
Yes. No, so I think it's the case if you read psychological literature, they usually have some kind of a motivation to motivate why they expect this kind of a bias. But competent psychologists could also come up with many alternative schemes to coming up with the same expectations. So they are not really anchored with the past successes. It's kind of there's some kind of a field there of kind of having some kind of consistent theoretical thinking there, but it's not really kind of situation that these discussions apply. But also, the point you said first that we have these models that don't really describe how things work. I think this is a revitalization of the instrumentalism debate. What are the proper goals? And I think I didn't bring up the quotes, but one of my motivations was to kind of make sense what Duncan Watts is actually saying. Is he saying that it's instrumentally good to produce predictive theories because that leads to better explanatory theories? Or is he saying that we should give up these kind of basic science goals and move to practical problem solutions? And it's a little bit kind of wavering between these. But the other one is about what are the aims of science and kind of changing the discussion. Another one is kind of a maybe sensible proposal how to actually proceed in developing theories.
Or to move, I agree that it can be read in different ways. But it could also be read as an argument that we should move to another type of theorizing.
Yes.
We should forget this old, because sociologists are not good at or the vocabulary, the so on that we typically use. I mean, with action theories and so, they are so poor, they are so behind, and it's just imaginary that we should be able to say something real with those. So we should move to some other form of type of theorizing.
Yes, but he also is making claims about testing.
Yeah.
Which are belong to here and not really about explanation. So, but that was my motivation, kind of come up with the. So think this through and then try to reply, which kind of sorts things out. Jacob had a comment at least 5 minutes ago.
Yeah, and it's actually, I think it's quite related to this, but maybe approaching it from a different angle. And I'm trying to sort of work through some of the implications of the argument. One way of taking this is that I think of instrumentalism as being an attempt to kind of kick out metaphysics from philosophy of science. And one way of taking this is that if every prediction, we can't do that with prediction, right? Every prediction has a kind of accommodative moment, then the strong version of this is that the sort of distinction between prediction and explanation collapses, right? And then this is more of a kind of rhetorical move. I have less metaphysics than you do. So first of all, my question one is, would you subscribe to that strong version of this claim? And question two is, would that apply equally to theories that are being tested and theories of data production. And I really like this idea of theories of data production, this distinction between data and phenomenon, although here it seems to me that we're in a kind of puzzling world where we tend to have very poor or very poorly articulated theories, but tend to be very strong realists. Like we believe that our data is real, that the machine is real, even if we don't know why we, even if we can't clearly explain or don't have working knowledge of what's actually happening there, right? And here too, you returned in the presentation to the language of prediction, right? Out of sample prediction as a way of evaluating the machine rather than our theories of data production.
Yes, I don't know whether I can give systematic answer here, but starting from the theory of data production.
Right.
This is quite informal. This theorizing, and it's about theorizing about the causes. I think even strongest empiricists, if they are real scientists, they are actually involved in this. And this is I think, nice counterexample of them, their abstract ideas that we can do without causes, because they are, in this context, taken seriously. But then this theorizing is really kind of quite often quite vague, unarticulated, so it's kind of in principle we could make the case and so on. And it's also interesting that it's not necessarily mechanistic explanatory understanding, in a sense that, like the example of the Galileo's telescope. So it's more about kind of having general understanding of about the conditions in which instruments are reliable, and what kind of inferences you can make reliably from them. And this is and of course these issues about testing theories could basically, of course, apply here, in a sense that you're testing your theory about the reliability of the instruments, and then you're making predictions that in these conditions it would create reliable or trustworthy results, but in other conditions you would get highly scattered results and so on. So you can kind of revisit these abstract debates here, but I think the contrast is important. And about the instrumentalism, if you really take these things seriously, then I think you are very limited instrumentalist. And I think this is the basic tendency in philosophy, that you kind of unobservable things, because there might be alternative theories and so on. You tend to be skeptical and avoid them. So it's enough that the theories are empirically adequate rather than fully true. But I think they tend to accept this more mundane reasoning, but then maybe take out kind of metaphysical aspects of it. Think about how one Frasen would respond to it. I think he would accept this stuff, not necessarily describe it in causal terms, but then point out that, going beyond the observable, then that's the problem. And then the realist will point out that, what is observable is actually flexible and it's changing, and it's not actually referred to what is observable by naked eye or something like that. Yes?
I have a question more related to methods, because there are certain approaches, at least in their stylized form in the social sciences, that map on to the prediction and accommodation, as you explained, right? So the kind of inductively driven, generally quantitative social science work is an example of a predictive type, where you're testing some hypotheses, and something more like ethnographic work falls in its stylized form more under the accommodation umbrella. But something like agent-based modeling to me is less clear. Where would you say this fits? Because I could see that, for example, most people who are building these models start with something that we might call predictive, and that there's usually some kind of hypothesis or some theories in the background, right? That they use to imbue characteristics into their agents, right? Because they need some reason for giving them actions or characteristics. But then once you sort of run the simulation, if you're looking into what produced the phenomenon that emerges, right, and you're going under the hood to see the process, right, that seems to be accommodation. Is that a correct way to think about this?
Yeah, well, of course, you could have simulations where you basically just you will be satisfied when they get things right, predict things right. Then you are kind of a predictivist, instrumentalist. But then most of the work, I think, is actually accommodation, in a sense that you build up the simulation, the certain data set and so on, and then get it work there, and then you try to see whether it works in other data set. And then in that case, you are starting to do predictive testing with the simulation if you are interested in kind of predicting the outcomes rather than analyzing what happens inside the simulation. So you have these theoretical toy models where you basically are not doing any kind of empirical testing, you are just trying to figure out how things might be related to each other. But then you have these empirical simulations. But I think you can, if you go through all the variations, you can find basically analogs for most of the cases you can find without simulation. But I think I started to think about this, thinking about tomorrow's lecture. So I'm talking about case studies, and sometimes case studies are challenged on the basis that okay, you didn't have a pre-established first stated hypothesis, so you weren't testing anything. So it's just a kind of an ad hoc story. So the case study shouldn't, or the ethnography shouldn't give you any credence, and I think that's highly unintuitive. Given kind of what's happening there, and that's one motivation of kind of thinking this through. So how do you answer to these people? What they have misunderstood? So it's clear that the hypothetic method is kind of a format for reporting research results, and it has a similarity to some things that are that you do, like a statistical testing. I'm not going to revise that, but then as a characterization of scientific method. I think there's a kind of a boundary we should explore, because that really emphasizes the role of prediction and downplays the value of accommodating data, although that's what actually is happening. So the discussion about HARKing, I think, is interesting because it's unclear. There's a lot of discussion about what's wrong about it. Of course, it's wrong to lie. And it's misleading to say that your ad hoc hypothesis was the original hypothesis, so that gives a wrong information about how you designed and so on. But what's wrong with kind of a post hoc exploration? And why that's not accepted in a journal publication, so that people have to kind of falsify the process to get the stuff published. And I think this raises interesting questions about how ideology about the scientific method affects negatively the scientific output by kind of incentivizing people to misrepresent their research. Yes?
But is it not enough reason to say that predictivism solves the problem of inductivism while accommodation does not? So in terms of how, at least as far as I know, how Popper defined it, like the problem of inductivism, right, is how you derive global statements about how things work, departing from empirical observations. And as I see that, accommodation is actually doing this. But this is defined as a problem, not as a solution of making explanations. Whereas the predictive departs from, I mean, it can use the data to get inspiration on how things work. Of course, it always should be like that. But you first start with a theory and a set of assumptions that make some deductions, and then you test those deductions. And it is in this process in where you basically skip the problem of induction, but you still generate knowledge that can be falsified and make predictions in the real world.
I think this is a more local problem than the general problem of induction. So generally the problem of induction is about the uniformity of the world and so on. So and this is more about the very local problem of what is the relation between the evidence and the theory. So I also remember that well, I think it's in objective knowledge. Popper says that I have solved the problem of induction. My copy of that book is a old copy from as Albert Kivinen was the philosophy teacher when I was a student, and in his copy it says that only you think so.
So
yes.
You made reference to Bayesian statistics.
Mm-hmm.
Do you see it as a way for us to get from this dichotomy of prediction to the level of accommodation? Because Bayesian statistics allows us to have a degree of belief, and also gives us the opportunity to like test different causal paths.
Let's put it this way, there's going to be a version of Bayesianism that deals right with these issues, but the problem is that there are at least as many forms of Bayesianism as that there are Bayesian philosophers. So my point is that by itself it doesn't contain enough structure. So it might be that you want to have an intelligent discussion about it, you are using Bayesian tools, but as the issue is how you update your belief, what are the grounds for updating your beliefs, you need something else than the Bayesian apparatus. And that's the kind of a difficult part in this debate. So that's why I kind of skipped the Bayesian solution by pointing out that people have given Bayesian suggestions in any possible way. So this implies that the Bayesian account is not necessarily Bayesian statistics, these are philosophers, so it's just Bayesian thinking is too flexible to solve this problem. But I'm not saying that it's unhelpful, but I think we need something else than just the Bayesian idea of updating your beliefs.
So you're not saying you don't think we can update beliefs, because I'm thinking about how statisticians approach this, right? Updating the beliefs based on one prior beliefs, and then you see the data, and then you update your beliefs again.
Yes. My point is that if you look at these cases, and people have different intuitions about them, you can all describe all alternatives in Bayesian terms as updating your beliefs, but the question is how do you update the beliefs? That's a kind of a challenge to articulate what are the grounds for updating your beliefs, and if you don't have kind of a clear answer to that, then you can basically formulate these all alternative theories in Bayesian language. So basically all these can give a Bayesian reconstruction of the idea of severe testing and fudging and so on. So it's more like a language to describe the problem rather than the source of solution. So all these ideas have Bayesian implications, but then how to choose right account that has to be done in some automated ways.
Okay, Petri, it's time, it is. Thank you very much.
Thank you.